Hi guys. Today you've got a little video on transforming trig functions. Transforming trig functions, and what I mean by transformations of trig functions is the same way that we transformed functions in Math 3. The one you probably saw the most in between Math 2 and Math 3 was transformations of parabolas, which looked like this. So we had the parabola, and you guys don't need to write this down. I just want you to be able to relate this to something you have done before. So this would shift, this h and k value would shift the vertex of a parabola over h and up or down k. And then this a was what we called kind of like a stretch factor. So that was elongating or smushing down the parabola. So that's the same concepts apply to trig functions: sine, cosine, tangent, secant, cotangent. We're just focusing on cosine and sine today. So there's one extra parameter, and by parameter I mean like a, h, and k. Those are parameters that affect the graph differently. So let me show you the graphing form for sine. So we're going to start with sine, and then the same exact concept applies to cosine. So, and tangent. But like I said, we're just going to focus on sine and cosine for now, just to kind of get used to it. So a times the sine. So again, a out front, just like with our parabolas. A times the sine of, now here's a new parameter, b times x minus h plus k. So the h and k operate the same way they did here with parabolas. So h is shifting it right or left. It determines, and I'm going to jump down here for horizontal shift. H determines the horizontal shift. But with trig functions, we don't call it the horizontal shift. We actually call it a phase shift. So the phase shift, when you hear me say that, what I mean by that is the horizontal shift. All right, so when you hear me say phase shift, that's the horizontal shift. The value of k determines the same thing it did with any other function, and that was the vertical shift. No special word for that, just vertical shift. Okay, so A is still the stretch factor. It determines, we don't call it like a stretch factor. We say what we talk about with sine and cosine is the amplitude, which is how high it is from the midpoint to the top or bottom of the curve or the wave. So the A determines amplitude. And then this value b here helps us determine the period of the sine or cosine or trig, whatever trig function. So how often it occurs. And b is the number of times that one cycle of the sine function occurs within the normal period of a sine function, which is 2 pi. So, and you guys will see me apply this in a couple of examples. So before we jump into transforming these trig functions down here, these two examples that we're going to do together, before we do that, we're just going to break down the process of graphing cosine and sine. We did this in class, so I'm not going to break it down like it's the first time you're seeing it. But I do want to make sure you guys can build these cosine and sine graphs on your own with confidence. So I'm going to do what you've seen me do a million times in class, and that is sketch just the 5 key points on my unit circle. So my unit circle consists of 2 pieces, the radians. So this would be 0 radians, and it's also 2 pi radians, and that's the rotation of pi halves, the rotation of pi, and the rotation of 3 pi halves. So my 5 key points consist of those, even though there are only 4. But once we get back here, so 0, pi halves, pi, 3 pi halves, and 2 pi. Those are my 5 key points that will make graphing sine and cosine really quick for us. So my ordered pairs are very simple here. Right here, I'm over 1 up 0, over 0 up 1, negative 1, 0, and 0, negative 1. So again, this sketch, I would expect to see this on a lot of your different homeworks, just so that you can quickly reference these 5 key points. Okay, So the sine of x, we have already established and reestablished several times how these xy coordinates here are the the cosine theta comma sine of theta. So we've already established this. The x values are the cosine of the angle of rotation. The y values are the sine. So when I'm graphing the sine function, I'm focusing on the y values of my 5 key points or any other points around the unit circle. So, and remember, our x-axis here is representing the angle of rotation that I'll call theta here. So when I have rotated 0 degrees, my y value is 0. So my first ordered pair on my sine function is 0, 0. I'm going to scale these. These aren't labeled. I'm going to make 1 and -1. Scale them like that. Okay, so now I'm going to go to my next key point, which is the rotation of pi over 2. When I rotate pi over 2, the sine of pi over 2 is 1. So on my graph here, pi halves, my y value is 1. I'm going to continue. When my rotation is pi radians, my y value is 0. So I've gone up to 1. At pi, I'm back to 0. At 3 pi halves, my y value, or sine of 3 pi halves, is -1. And then on my fifth key point at 2 pi, same as 0, my sine is back to 0. So I have graphed one period of the sine function. So I see that repeat at 2 pi. So that's why the value of b up here, so I'm going to reference this here in a few minutes. That number right there is how many times the sine function repeats within a period of 2 pi. So I would have to do that math and adjust it based on what that number is. Okay, so we'll also do cosine. So same thing. We've already discussed, cosine is all of the x coordinates of these ordered pairs on the outside of the unit circle. So I'm going to just jump right in. The cosine of 0 degrees or 0 radians is that x value right there of 1. So I'm going to scale this the same way I scaled my other one. Cosine of 0 is 1. So we see the sine function starts at 0, 0. We see the cosine function starts at 0, 1. At pi halves, the cosine function is 0. At pi, so we're going around to pi, cosine is -1. To 3 pi halves, cosine is 0 again. And then up to 2 pi, and the cosine is back to 1. So we see one period of the cosine function like this. The reason I'm starting this section with these simple parent graphs of the sine and cosine function is because you're going to basically be sketching 2 graphs on each of our examples. You're going to sketch, and I'll explain this as I walk through these. First, you're going to sketch the cosine function with the given amplitude and period. Then you're going to take that sketch and finalize it by applying the phase shift and the vertical shift. So let's walk through this first one. Oops. Okay, really fast, I'm going to just copy this equation down here so that I don't have to keep moving my paper. So this was that the a sine of b, which determines our period, x minus h plus k. All right, so taking this and then applying it to these 2 examples here. So I'm just highlighting that because I'm going to reference that several times. So I can see very quickly the amplitude is 3. So that's always the number up front. Yes, I'm working with a cosine function here. That's fine because I can easily graph cosine like we just did. So the amplitude is 3. And now the period. So the period is determined by this value of b, and that is the number of times that the cosine function will repeat in a period of 2 pi. So if my cosine function happens 2 times in 2 pi, Then I just want to know the period, which would be how many radians does it repeat one time, which would be 2 pi divided by 2. So the period is always going to be this. I didn't explicitly write that up here, but I wanted you guys to think. If B tells us how many times it repeats in 2 pi, then the period is always going to be calculated by doing 2 pi divided by B. So 2 pi divided by 2 is just pi. So that's going to repeat in 1 pi. The phase shift is whatever that h value is, the horizontal shift right here. So negative pi fourths. The formula itself is x minus h. So h itself is positive pi over 4. And that's the amount that I'm going to shift that horizontally, pi fourths to the right. Pi over pi. And then lastly, the vertical shift, which is simple. It's just this minus 2 out here. That means we are shifting down 2 units. Like I said, in a lightly colored, in a light shading with a pencil, we're going to graph this first, and then I'm going to take my original cosine with amplitude 3 period pi, and then I can do the vertical and horizontal shift. It's just much easier to piece together when you do it in these two parts. I apologize because the lines on your paper are, when I made copies, it made it really hard to see the actual grid lines, even though they were there originally. So just bear with me. You should be able to see them a little bit. All right, so this is the cosine function. Reference this if you need to. My original cosine parent function starts at 1. It ends at 1 at 2 pi. In this case, though, because my period is pi, so that is going to be one full cycle of the cosine is going to start and end there to there. However, with an amplitude of 3, instead of starting at 1, it's going to start at 3, and then it's going to end at 3. Okay, my grid lines are really difficult to see. All right, so I've got those 2 points. Right in the middle, it's at negative 1. So this is kind of my process. It's going to start and end at the same point, and then right in the middle, it's actually at negative 1. So instead of negative 1, at pi halves, it's going to be negative 3. And then we can see this already coming together. And then at pi fourths, in between 0 and pi halves, it's going to be at 0. So basically, I'm taking this pattern here, squishing it down into a period of pi, and then I'm applied the amplitude of 3 as well. So lightly with your pencil, we're going to sketch that one, and this pattern would continue. So over at 2 pi, I would be back at 1. Halfway through, I would be at negative 1. At 4 pi or 5 pi fourths. So you can continue on. But my final graph, I'm going to apply now the phase shift. So this phase shift of pi over 4, positive pi over 4, notice how my graph is scaled by pi fourths. That means I'm shifting to the right 1 unit because one of my tick marks is pi over 4, and then a vertical shift of 2, so that's just down 2. So every single point that I've just done, I'm going to shift right 1, down 2. And I'm just going to go right to left. So then this point would go right 1, down 2. This point is right 1, down 2. Right 1, down 2. And if you go in order and kind of stay organized, you will be in good shape. So you don't have to graph 2 full cycles of this, but I just like to get a full picture. So now that I've shifted, I will draw my final graph in, either darker in pencil so it's clear, or just grab a colored pencil or pen. Okay, and then that would be here. So that's the final result. Okay, let's do one more, and then you guys, the back of this, I'm going to have you guys complete independently before submitting to Schoology. So my second example here is a sine function, and I'm going to start by just identifying all of these features of the graph. So the amplitude is the coefficient A out front, which is just 1. The period with this one, so 1/4. Again, that number 1 over 4 indicates the number of the sine how much of the number of complete cycles of the sine function that takes place from 0 to 2 pi. If only 1/4 of it takes place from 0 to 2 pi, then one full cycle of the sine function would take 8 pi. Another way is just apply this 2 pi divided by b. So the period is 2 pi divided by 1/4, which is 2 pi times 4. So we end up with a period of 8 pi. So that just means it's being stretched out by a factor of 4. So, and you'll see that this graph was intentionally scaled to go out here to 8 pi. So I'm working with the sine function. I have the amplitude and period. I will note my phase shift, although it is x plus pi, remember the formula is x minus pi. So my phase shift is actually negative pi, which if we look on our scale, unfortunately, my intervals of pi, those were marked on there, but they just didn't copy well. So that means I'm going to shift it left pi, which was 1 unit on here. It's just hard to tell. And then the vertical shift, my plus k is 1. So and you'll see here the 1 is one of these full darker boxes. So up 1. All right, again, I'm gonna do this first in pencil. So first I'm graphing a rough sketch, including the amplitude and period of this sine function. Again, sine was starting at 0, 0, it ended at 0, it was 0 in the middle, and it was 1 and -1 at those the pi over 4, or pi half marks. So this one, amplitude of 1, period of 8 pi. So my sine function, again, I'm not applying the phase shift or vertical shift yet. So I'm starting at 0, at 8 pi, I'm ending at 0. It's also 0 right in the middle. So I've got these 3 points immediately. And the amplitude is 1. So in between here, at 2 pi, I'm at 1. And at 6 pi, I'm at -1. So this is a really quick sketch of my sine function with amplitude 1. We're just stretching it out over a full period of 8 pi. Now I'm going to apply my phase shift and my vertical shift. So my phase shift of -pi. So if this is 2 pi, then 1 pi is the distance from here to here. So I can't really shift this left. I guess I could, and then go up 1. So that would be roughly like -pi, and then up 1. So we are going -pi units left. So this one now would go -pi and then up 1. This one is going -pi, up 1. So as you can tell, I go in order of all my points. To the next point, -pi, up 1. To my last point, -pi, up 1. And then you can kind of see visually how we're piecing this final graph together. So I'm going to draw my curve. So this was shifted up 1, but just shifted kind of half of one of those boxes. So that's the final result. So I'm going to stop here and have you guys complete these 4 graphs on your own. Remember to do amplitude and period first in a lighter pencil or a different color, and then do your final one after applying phase shift and vertical shift if that is necessary. All right, so the back of this sheet, you've got 4 graphs, and then these last 2 problems, I give you the graph and I want you to write the equation. So this is what I want you guys to complete on your own, and I'll take questions on this when I see you in class next time. Have a great day.